This question is Edexcel M1 2016 October 3rd question. Here the question is about moments. We can see a figure here. A plank AB has length 8 meter. It is 8 meter in length and its mass is 12 kilogram. As its mass is 12 kilogram, its weight is 12 times 9.8 Newton. Will act down through the midpoint as it is a uniform plank. Twelve times 9.8 Newton is the weight. The plank rests on two supports. Two supports are C and D. One support is at C, where AC is 3 meter given, and the other support is at D, where AD is given as X meters. Then a block of mass 3 kilogram. This is the block. Its mass is 3 kilogram, so its weight will act down. That is 3 times 9.8 Newton. Is placed at B. The plank rests in equilibrium, so the whole system is in equilibrium in the horizontal position. The magnitude of the force exerted on the plank by the support at D. So here there is a contact force, normal reaction force. That is twice the magnitude of the force exerted on the plank at C. So what is the force acting here? For example, if it is R or RC, here it is 2 times R. If the normal contact force at C is R, then the normal contact force at D is 2 times R, twice the magnitude of force at C. Then the plank is modeled as uniform rod and the block is modeled as a particle. Find the value of X. This is the question. Distance between, or the length from A to D. What is X? Here, to solve this question, we can use the conditions for equilibrium of a system about these supports. Anyway, here two conditions are there for a rotating system to be in equilibrium. Here the total forces acting down must be equal to total forces acting up. That is one condition. Another one, total clockwise moment about a pivot is equal to total anti-clockwise moment about the same pivot. In this case, we can take any of the points A, C, D or R as the pivot. Okay, so first we can find an expression for R, then we can find the expression for X. That is the question. So I am using the concept as it is in equilibrium. We can say total upward force acting on the plank is equal to total downward force. This statement is not compulsory to write in the exam. This is to teach. Here the total upward forces are this normal reaction at C and this normal reaction at C and this normal reaction at D. Total downward forces are the weight of the plank and weight of this block. So total upward forces are plus 2R is equal to total downward forces 12 into 9.8 plus 3 into 9.8. So 12 plus 3 into 9.8. So by rearranging we will get 3r is equal to 15 times 9.8. So r is equal to 15 times 9.8 divided by 3, that is 5 times 9.8, that is about 49 Newton. You can use the calculator. So 3r is equal to, so r is equal to 15 divided by 3 is 5. 5 times 9.8 is about 49. Then this is the value of r, normal reaction at C. Then normal reaction at D is 2 times r. So here it is upward force 49, here it is upward force 98. Then our question is to find x. So we are going to solve that. Here I am using the concept of total clockwise moment is equal to total anti-clockwise moment about any pivot. I am taking this point C as the pivot. So it has a tendency to rotate this way or this way. Here the clockwise moments are about C. The clockwise moments are due to this force and due to this force. That is the weight of the objects. And the anti-clockwise moment is due to this force. So here the clockwise moment due to the weight is, we know these distances, it is total given, the length is 8 meter, this is 3 meter, so this is 4 meter, so this is 1 meter. Once more, the length of the plank given in the question is 8 meters. So weight, we know weight is always acting through the midpoint. So this length is 4 meters. As it is 4 meter and it is 3 meter, this length is 1 meter. Okay. So this length from the considering pivot to this force of weight is 1 meter. Then we need this distance also. This total from A to D is x. This is 3. So this between C and D is x minus 3. Okay. Then the distance of this force from this is total 8. This is 3, remaining 5. So this distance is 5 meters. We need this length to solve the moments. So I am going to solve the moments equation. What is the condition? Total clockwise moments. Now we are considering the pivot as C. So we are at about C is equal to total anti-clockwise moment about C. This is also not compulsory to return in the exam sheet, answer sheet. Anyway, better. Then total clockwise moment is sum of the moment due to this one and due to this one. Moment due to the weight is 12 into 9.8 multiplied with this length 1. Moment due to this weight is this weight into this distance. These are the clockwise moments. So 12 into 9.8 is a force times the distance is 1 plus another one 3 into 9.8 multiplied with the distance is 5 is equal to anti-clockwise moment is this one 2r times x minus 3. So it's equal to 2r times x minus 3. Use the calculator. Into 9.8 times 1, so it is 117.6 plus another one, 3 times 9.8, 29.4 times 5, 147 is equal to, here the R is 49 we know, so 49 times 2, 98 into x minus 3. So here adding on the left side values 147 and 117.6. $264.6. So 264.6 is equal to into x minus 3. So x minus 3 is equal to 264.6 divided by 98 is equal to divided by 98 is equal to 2.7. So we got x minus 3 is equal to 2.7, x is equal to 3 plus 2.7 is equal to 5.7. All others are in meters, so this is in meter. So this is the answer for the x, solving x. Okay, so we use the concept of equilibrium. Total upward force is equal to total downward force, and total clockwise moment about a pivot is equal to total anti-clockwise moment about the same pivot. Here I took C as the pivot. We can take any of that, C or D or B or A as the pivot. So in the question we solve first, what is R? R is the normal reaction force acting at C, and tau is that is acting at D in the question. So total upward force is sum of the two. Total downward force is the weight of the block and the weight of the plank. Then from that we got the value of R. Then we put that value in the equation of moments. Then we are getting the answer for x. Okay, thank you for watching.